Buffers. A buffer solution, well, let's think about what is a buffer? They talk about buffers in Thomas the Tank Engine videos. You guys ever watch Thomas the Tank Engine? Well, it wasn't an accident, but 2 of my children are named after, actually 3 of them are named after, not after, but have the same names as. There's James, the red engine, and Thomas, the tank engine, and then there's Emily. Emily is one of the engines also. Anyway, they talk about buffers on the train track. Do you know what those are? They're like bumpers at the end of the line to keep the train from running off. They kind of cushion, right? If you think about a buffer zone, it's sort of a no man's land, right? It's sort of a cushion. A buffer solution sort of cushions the pH, okay? It resists changes to pH. We'll do the bottom of this slide first. Your blood is a buffer solution. Your blood resists pH changes. And this is a really good thing because your blood pH normally is between 7.36 and 7.40, pretty tight range. If it drops below 7 or above 7.8, you're going to die because it messes up all kinds of biochemical processes in your body and you will cease to be alive. So your body, through a buffer system, carefully regulates the pH of your blood. Well, buffers work because they have significant amounts of a weak acid and its conjugate base. So let's just do a generic weak acid. So HA, and if we add that to water, this will be in equilibrium because a weak acid does not dissociate completely. The weak acid is a proton donor. It's going to donate a hydrogen to the water, which is going to accept it because it's acting as the base. And so we'll get that hydronium ion, and we'll get the conjugate base, which is the ion of that acid. So in a buffer solution, you have significant amounts of the weak acid and the conjugate base. And what happens when you add base to this solution? Well, the acid reacts with it. And if you add acid to the solution, the conjugate base reacts to it and neutralizes it. And so it can maintain the pH. And you'll get a chance to do that in lab today, challenge some buffer solutions and see how they change. So acetic acid, sodium acetate, is a buffer system. Acetic acid is the weak acid, and sodium acetate is the conjugate base. Acetate is what you have left after you take a proton off of acetic acid. So if we add sodium hydroxide to it, the acetic acid reacts and neutralizes it. If we add acid, the conjugate base reacts and neutralizes it. So whether we add acid or base, it can handle it and neutralize it. Here's the same idea in picture form. So here's the weak acid. Most of it is, we have significant amounts of both the weak acid and its conjugate base. So when we add acid, the acid reacts with the conjugate base and gets neutralized. Over here, we're adding sodium hydroxide, we're adding base. It will react with the weak acid and neutralize it. So that's the idea behind a buffer. So what do you need to know about buffers? Probably about the only question I would ask on the final is something like this. Which of the following is a buffer solution? Well, how can we tell? What did we just say a buffer was? A weak acid and its conjugate base. So as we look at these, do you see any that do not contain a weak acid? What about this one at the bottom? Is either of these a weak acid? No. That's just a salt. It's not acidic or basic. And what's this? That's a strong base, right? So that guy's out of the running. That one's not a buffer system. Let's just work our way up from the bottom. Is HCl an acid? Yeah. Is it a strong acid or a weak acid? It's a strong acid. And how do we know that? It was on the list. Yeah, somebody asked me to explain how I knew that. He was, the explanation was really short. I said, it was on the list. Oh. Yeah, there's no fancy reasoning or anything. There was that list of 6, and those are strong acids, and the rest of them are not. This is a strong acid. This is the conjugate base, but we need a weak acid. So this isn't a buffer system. How about this guy, HF? Is that an acid? Yeah. Is it a weak acid? Yes. Okay, what's the conjugate base of HF? So we've got HF, and the conjugate base will be when we remove a hydrogen ion, right? So F minus. Does this have a F minus in it? Yes, it does. So this one is a buffer system. We've got the weak acid and the conjugate base. How about this first one? Is this a weak acid? It's a strong acid. It's an acid, but it's on the list. How about this one? Is this one on the list? No. Here we have a strong acid and a weak acid, and that's not going to cut it. Any questions? Chapter in review means we are done. That is the end. See you Tuesday here.